Welcome back to our Math 171 video series. In this series, we'll deal with transformations of graphs. This problem gives us a graph and then asks us to modify this graph using the modified function negative fx minus 2 plus 3. There are three modifiers on this function. The first modifier is the negative sign in front of the fx, which I'm circling in green. The second modifier is the minus 2 that we see inside the parentheses. And the third modifier is the plus 3 that we see on the outside of the parentheses. Each of these modifiers will change the picture. Based on that, we can sketch the graph. Let's go over what the modifiers mean. We'll start with the plus 3 on the outside. Numbers on the outside are called vertical shift modifiers. A vertical shift modifier moves the graph up and down. A positive number moves the graph up, and a negative number moves the graph down. Effectively, you will be adding or subtracting your vertical shift from all of the y values on the graph. Since we have a plus 3 on the outside, and that is our vertical shift, all of our y values in this picture will all go upward by 3, because positive means upward. Therefore, we will add that 3 to all y's. Next, we'll talk about the minus 2 inside of the parentheses. Numbers on the inside of the parentheses are horizontal shift modifiers. These will move the graph left or right. When we're dealing with horizontal shifts, a negative number means shift right and a positive number means shift left. This number will modify all of our x values based on the modifier. Now we have a negative 2 inside of our parentheses. That negative number means that we are going to shift all of our x values right by 2. Now, shifting right on the graph means our x values are going up, so all of our x values will go up by 2. This is a little bit counterintuitive considering that we do have a negative sign attached, but we have to remember that inside the parentheses, the negative sign means go right. It doesn't necessarily mean subtract. All x's will get a plus 2. The number on the outside of the parentheses before the f is your vertical stretch modifier. This vertical stretch modifier will multiply all of the y values by whatever that number is. If that number is negative, this will also change the sign of all of the y's. Note that if there is no number but there is a sign, we can treat the number as negative 1. This means that all of our y's will be multiplied by negative 1 in this case, seeing as how we have just a minus sign. With these things in mind, let's now try to draw the new graph. I've rewritten all of our transformation modifiers underneath the function. We have a right shift of 2 because of the minus 2 on the inside, a times negative 1 because of the negative 1 on the outside, and then plus 3 after the negative fx minus 2 will mean an upward shift of 3. Remember that we said the right shift of 2 was horizontal and the upshift was vertical. Also, that negative 1 is effectively a stretch. Now, when we do transformations, we handle the horizontal modifiers first. So we'll do the right shift before we do anything else. Then we'll handle the stretch next. And then we'll handle the vertical shift third. This will be the order of operations anytime you're dealing with this type of transformed graph. Horizontal first, stretch second, and vertical shift third. Now that we know this, let's write down the positions of the key points on this graph. I'll mark some points on the graph now, starting from the left and working our way right. The first point I'm going to place is this dot in red where the graph begins, and that is at -2, 2. We'll mark another one at the top of this triangle, and that's 0, 4. We'll mark another at the other side of the base of the triangle, which is 2, 2. We'll also mark the other end of this blue line, that's 4, 2, and we'll mark the end of the graph on the right, that is at 6, 0. We'll write down all of those points on a list. Our first move is going to do a right shift by 2, which we said effectively adds 2 to all of the x's. Notice that this does not modify y yet, so all of our y values will stay the same. Whatever y values we had previously, we will still have at the end of this first step. However, all of our x's will go up by 2. Therefore, this -2 we start with in the first point. If we add 2, we will get 0. If we start with 0 and add 2, we will get 2. If we start with 2 and add another 2, we will get 4. Then 4 plus another 2 gives 6, and 6 plus another 2 gives 8. These are going to be our new points at the end of the first step. Then for step 2, we're going to do our vertical stretch. When we do our vertical stretch, that means all of the y's will be multiplied by -1. That means that for this step, the x values do not change. They will stay the same as whatever they were from the previous step. So the 0, 2, 4, 6, and 8 that we had previously will stay exactly the same. However, we'll multiply -1 times all of our y's. This will change their signs. So 0, 2 becomes 0, -2. 2, 4 becomes 2, -4. 4, 2 becomes 4, -2. 6, 2 becomes 6, -2. And 8, 0 remains 8, 0. Now for our third step, we will do an upward shift of 3, which means all of our y will gain +3. This means for this step, our x's once again do not change. They remain 0, 2, 4, 6, and 8. However, all of the y's will gain 3. Therefore, if we start with a y of -2 and we add 3, we will get 1. Start at -4 and add 3, we will get -1. Once again, start at -2 and add 3, we already know that gives us 1. This will also be the case for our next point. And then 0 plus 3 will give us 3. These will be our final points because now we have completed all of our operations. With these points, now let us try to construct a new graph. I've copied the points onto this new slide. We'll begin by marking a dot at 0, 1 to show that as our starting point. We'll continue forward by 2 spots and drop down to -1. This will be 2, -1. Then we'll move to the right by 2 more positions and we'll make a mark at 4, 1. Move 2 more positions forward and make a mark at 6, 1. Finally, we're going to move upward and right by 2 positions, giving us 8, 3. Then to finish the graph, we connect the dots. This will be our completed graph for the transformed function, -f of x minus 2 plus 3.